The topic of these notes is more on unit rates. The essential question is, can you find unit rates in situations that do not involve cost, distance, or time? So you've learned that in situations that deal with cost or distance, that these terms typically go in the numerator. That's the top part of the decimal, or fraction. Okay, the top number of a fraction. And then terms that involve time usually go in the denominator when finding unit rate. But there's going to be times when situations don't deal with cost, distance, or time. So under those circumstances, that's when you're going to need to think about which item needs to equal 1, okay? The term that needs to equal 1 will go in the denominator when finding unit rate. So the term that needs to equal 1 goes in the denominator. So it goes in the bottom part of the fraction. Okay? So go ahead and answer this summary, fill in the blanks. Yes, write it all out. Typically, time goes in the blank, and cost and distance go in the blank. However, if you need a value to equal blank, that term should always go in the blank. If you're not quite sure, reread what you wrote up here, then turn the page. Find the unit rate in each situation. Ariana uses 12 cups of pretzels for every 3 cups of raisins when making a snack mix. How many cups of pretzels will Ariana use for 1 cup of raisins? So you see in this example, it has nothing to do with cost, distance, or time. So this is where you need to decide, well, which term needs to equal 1? Because the term that needs to equal 1 will go in the denominator, which is the bottom part of the fraction, okay? So what I look at is I look at this last sentence right here. How many cups of pretzels will Ariana use for 1 cup of raisins? So this is implying, hey, I need cups of raisins to be on the bottom in the denominator because I need to figure out how many cups of pretzels for every 1 cup of raisins are needed for this snack mix, okay? So I know raisins is going to go in the denominator. So therefore, pretzels, the cups of pretzels goes in the numerator. So I'm going to extract this information right here. So it's 12 cups pretzels, and make sure you label it. And for that, it's 3 cups of raisins. And look, this is actually a ratio because we're comparing cups to cups, okay? So right there, that's that ratio. And to find the unit rate, we want to know how much it costs for 1 cup raisins. And not costs, sorry. How many cups of pretzels we need for 1 cup raisins. Okay, so 3 divided by what number is 1? Well, it's divided by 3. So we have to take the numerator and also divide that by 3. 12 divided by 3 is 4. So label it 4 cups pretzels per 1 cup of raisins. Okay? So Ariana will use 4 cups of pretzels per cup or per 1 cup of raisins. Okay. The next example says 8 bags of sugar weigh 12 pounds. How many pounds does 1 bag of sugar weigh? So I see this part in that last sentence right there. How many pounds does 1 bag of sugar weigh? Okay, so that's just kind of a hint that tells me that the bags need to go in the denominator. They need to go in the bottom part of the fraction, okay? So bags on the bottom, so it's 8 bags. And the top number, the numerator, would be 12 pounds because 8 bags of sugar weigh 12 pounds. Okay, so that right there is our rate. So to find the unit rate, because we want 1 bag of sugar in the denominator, you got to go 8 divided by what number gives you 1? Well, it's 8 divided by 8. So now I also need to go 12 divided by 8. And I got 1.5. Okay, so 1 bag of sugar weighs 1.5 pounds. Right, try the next one on your own. Try to set up that that fraction so you can figure out the unit rate. Okay, get your practice in. Okay, it says, so Anne makes a sugar-water mixture for hummingbirds. She knows the amounts of sugar and water are proportional. The recipe calls for 9 cups of water for every 1.5 cups of sugar. How many cups of water are needed if she only uses 1 cup of sugar? Okay, and you're probably wondering why I said that's so weird, because that kind of implies that we want the cups of sugar in the denominator, okay? Because we want to figure out how much water is needed for 1 cup of sugar. So I want cups of sugar on the bottom, the denominator. Okay, and what does it say? Sugar water, Mr. Rammer, calls for 9 cups of water for every 1.5 cups of sugar. Okay, so right here you see 1.5 cups, and I don't really like to keep that as a mixed number. So I know that I can turn it into a decimal. So one way that I can do this is by going, I know 1 is the whole number, and if I need to figure out what 1/2 is as a decimal, I can just go 1 divided by 2, the numerator divided by the denominator. I'll show you. And that's 0.5. So I know that the fraction, or the fraction, its decimal form would be 1.5, okay? Or another way that you can do this is turn this mixed number into an improper fraction and go 2 times 1, which is 2, plus 1 is 3, so it's 3/2. And you know this means divide, so 3 divided by 2, I'll show you what that looks like. 3 divided by 2 equals also 1.5, 1 5/10. Okay, so when I'm going to go ahead and set this up, 9 cups of water for every 1.5 cups of sugar. Cups of sugar was, 1.5, 1 5/10. And for the water was 9 cups water. Okay, so this ratio, we're comparing cups to cups. So let's go ahead and find its unit rate. We want 1 cup of sugar. So 1.5 divided by what gives you 1? Well, it's divided by 1.5, because any number divided by itself gives you 1. Okay. Well, I guess except 0, but anyway, that's a different story. 9 divided by 1 5/10 for the numerator is 6. 6 cups water for every 1 cup sugar. So Anne needs 6 cups of water if she only uses 1 cup of sugar. Okay. All right. These 3 examples did not involve cost, distance, or time. So how did you know which term should go in the denominator? You need to write down how you knew which term needed to go in the bottom part of the fraction. Which term went in the denominator? How did you know? Write that out. Then turn the page. The next example says, this diagram shows how much milk is mixed with flour for a recipe. How many cups of milk is used for 1 cup of flour? And again, this example does not deal with cost, distance, or time. So your little hint is to look at, that typically that last statement right there, or question mark sentence. How many cups of milk is used for 1 cup of flour? So right there, I see 1 cup of flour. So that implies, hey, I need flour on the bottom, the cups of flour. Okay. So now I know that it's not stated explicitly in the story problem, the amount, the ratio of cups of flour to cups of milk. So what I've got to do is I got to literally look at the diagram. So I see right here the flour for this mixture, I need 3/4 of a cup. And for that mixture, I would need 1, 2, 3 cups of milk. Oh, another dilemma is you see right here a fraction. And you can keep it a fraction if you like, but for me, because I like to type things in my calculator to double check, I like to convert my fractions into decimals, okay? So 3/4 as a decimal, its decimal equivalent, I can rewrite it as 3 divided by 4. And 3 divided by 4 should give you its decimal equivalent, numerator divided by denominator. And you get 75 hundredths, okay? So if you see 3/4 anywhere in any problem, you can rewrite it as 75 hundredths, okay? So I can kind of tell myself, oh, that means 75 hundredths. Same thing. Okay, so let's go ahead up and set up our ratio because I'm comparing cups to cups. So how many cups of milk is used for 1 cup of flour? The cups of flour have to go on the bottom, the denominator, so 75 hundredths flour. The denominator. And then so the numerator is 1, 2, 3 cups of milk. Okay, so that's my ratio. And now to find the unit rate, I need to figure out how much cups of milk is needed for 1 cup of flour. Okay, so 75 hundredths divided by what would give you 1? Well, you got to divide by itself, so 75 hundredths. Okay, and so if you divide the denominator by 75 hundredths, you need to divide the numerator by 75 hundredths. So I need to go 3 divided by 75 hundredths. 3 divided by 75 hundredths equals 4. So this would be 4, and don't forget to label it. 4 cups milk per cup of flour. So let's go ahead and write this. How many cups of milk is used for 1 cup of flour? There are 4 cups of milk used. Instead of saying for every 1 cup of flour, I could say per cup flour. Because that implies per cup means for 1 cup flour, okay? Same thing. You should try number 5 on your own. You should pause the video and see if you can figure out the fraction and, the unit rate all by yourself. All right, this diagram shows how much blue paint is mixed with white paint to paint Andrew's house. How many gallons of blue paint is needed per gallon of white paint? So I don't explicitly see the number 1, like I saw up here. It said 1 cup of flour, so I knew cups of flour needed to go in the denominator. But I do see this per gallon, implying 1 gallon of white paint. So therefore, I know white paint would go in the bottom part of the fraction, which is the denominator, okay? So I need white paint on the bottom, the denominator. So something white paint. Oh, gallons of white paint. I'm going to abbreviate it to gallons. Okay, but I have to get my information from this diagram right here because it's not explicitly stated in the story problem. So I see right here for blue it's 1, 2, 3, 4, and for white it's 1/4. Okay, so to convert from a fraction to a decimal, I would just go 1 divided by 4, and when you go 1 divided by 4, you should get 25 hundredths. Okay, so right there that's equal to 25 hundredths, 0.25. All right, so I can write 0.25, 25 hundredths gallons of white paint for 1, 2, 3, 4 gallons of blue paint. And from that ratio, we're going to find its unit rate. They wanted 1 gallon of white paint. So 25 hundredths divided by what number will give you 1? Well, it's 25 hundredths. Let me show you that. 25 hundredths divided by 25 hundredths equals 1. Okay, so now I got to go 4 divided by 25, don't forget the decimal, 25 hundredths. So 4 divided by 25 hundredths, and you get 16. 16 gallons of blue paint per every 1 gallon of white paint. That says 16 gallons of blue paint are needed for every 1 gallon of white paint. You could have also said 16 gallons of blue paint are needed per gallon of white paint. Same thing. Whatever your preference of how to word it. Okay, you do have to finish this. You have to answer this question, okay, for your summary. In these two examples, the amounts of each term were not stated in the story problem. So it doesn't specifically say, numbers in the story problem. What did you have to do to set up your problem? Where did you get these numbers? Because they were not in the story problem. Where did you get these numbers? Because they were not in the story problem. Okay, go ahead and answer that question and then turn the page, please. Number 6 says, the ratio of teaspoons of salt to teaspoons of pepper in a seasoning mix is 4:3. How many teaspoons of salt will be needed per teaspoon of pepper? So look how it's written right here as a ratio. And to distinguish what the 4 goes with and what the 3 goes with, you would just kind of look back up and see what the order was in the statement. So the ratio of teaspoons of salt to teaspoons of pepper implies that there are 4 teaspoons of salt. So I'm going to just label that so I don't confuse myself. Teaspoon is the abbreviation for teaspoon, TSP. That's what salt. And then this right here is teaspoon of pepper, okay? And it's a good idea just to kind of label that so you don't get the two confused later on, all right? Because that can be a common mistake. Now it's saying how many teaspoons of salt would be needed per teaspoon of pepper. So it's asking you basically, well, how many teaspoons of salt for every 1 teaspoon of pepper? So that implies teaspoon of pepper needs to go in the denominator, in the bottom part of the fraction, okay? So teaspoon pepper. Okay, and let me look back up here. How much was pepper? Oh, 3 teaspoons pepper. And it was 4 teaspoons of salt. Okay, now that right there is a ratio, so we need to set up to find the unit rate. And for the unit rate, we want to know how many teaspoons of salt per teaspoon of pepper. So we want 1 teaspoon pepper. That's why it goes in the denominator. All right, so 3 divided by what number gives you 1? Well, it's 3. 3 divided by 3 is 1. So now I got to go 4 divided by 3. And when you go 4 divided by 3, it looks like this. Whoops, like this. Type it in correctly, please. You get that. Okay? And I don't know, you go ahead and round it to the nearest hundredth. So that would give you 1.33 teaspoons salt per teaspoon of pepper. Now, if you're somebody that knows it's a repeating decimal like this, 0.33333, its equivalent fraction would be 1/3. So if you knew that, 1 divided by 3 is 1/3, you get 0.3333. So you could also write this as 1 1/3 teaspoon salt, okay? If you have that ability. But this could be fine for now. If it specifically tells you that it wants the fraction, then you would need to do this. But if it doesn't really explicitly say one way or another, I would typically round to the nearest hundredth, okay? If it's a terminating decimal, like a decimal that just stops like 1.5, then just keep it 1.5. Don't round it, all right? Or 1.534, then just keep it as 1.534. If it's a terminating decimal, meaning it stops, then keep that, okay? But if it's a repeating decimal or something that's really, really, crazy, long, irrational looking, then go ahead and keep it as a ground to nearest hundredth. Okay, anyway, so you need 1 1/3 teaspoon salt, or you could write 1.33 per teaspoon pepper. Okay. Okay, number 7. Try to do this one on your own. Jay likes to maintain a proportional relationship between the number of male and female horses he has. He currently has 17 male horses and 34 female horses. If Jay decides to sell all of his male horses but one, so you can have 1 male horse, how many female horses should he keep? Okay, so he wants to keep 1 male horse. And remember, it's got to be a proportional relationship between males and females, and the proportional relationship has to do with having 17 males and 34 female horses to begin with. And since he's going to only have 1 male horse left, we need the male horses in the denominator, okay? How many male horses were there? 17. And we got 34 female horses. So to find its the unit rate for this, we want 1 male horse left. So 17 divided by what number gives you 1? Well, it's 17. 17 divided by 17 is 1. So 34 divided by 17 is 2. We'll check that. Okay. Yeah, that's 2 female horses. So he needs to keep 2 female horses. Jay needs to keep 2 female horses. Because he wants to maintain that proportional relationship. All these right here, those are proportional relationships. Okay, Justice uses 1 1/4 tablespoons of peanut butter for every 1/2 tablespoon of jelly when making a sandwich. How many tablespoons of peanut butter does he use per tablespoon of jelly? So right there, I look at that, and the jelly's got to go on the bottom in the denominator, okay, when I'm setting this up. So jelly on the bottom. So we got jelly, 1/2 tablespoon of jelly. Okay, see right there, I got a fraction. 1/2 as a decimal, I go 1 divided by 2, and when you punch that in your calculator, or if you already just know it, it's 0.5 or 0.50 or 0.50000, same thing. Okay, so I'm going to show that as 0.5, 5/10. So jelly is 5/10 tablespoon. Okay, and I see right here I have 1 1/4 tablespoons of peanut butter. So 1 1/4 as a decimal. I know that the whole number is 1, so I can put 1 right there, and 1/4, okay, 1 divided by 4 would give me the decimal equivalent of 1/4, so I go 1 divided by 4, and I get 25/100ths. So I know it's 1 25/100ths. Or another way you can do it is converting this mixed number into an improper fraction by going 4 times 1 is 4, plus 1 more is 5, so 5/4 is equal to 1 1/4. And I can go 5 divided by 4 and get the same thing. 1 25/100ths. Okay, because 5/4 is also equal to 1 1/4, okay? So all these right here, these numbers are all interchangeable. So if you're like, I like this one the best, then you can cross that off and put 5/4 if you want. I don't care, it'll work. Okay, so 1 25/100ths tablespoons. Peanut butter. All right, so to find the unit rate, we wanted to know for how much peanut butter is used per tablespoon of jelly. So 1 tablespoon of jelly. That says TBSP. Okay, so 5/10 divided by what gives you 1? Well, it's divided by 5/10. So look, 5/10 divided by 5/10 is 1. See? Okay, and then 1 25/100ths divided by 5/10. Don't forget your decimal. Is 25/100ths. Sorry. My calculator has a weird thing right there. That's just a scratch. So it's 2 5/10. So it's a good thing that you're doing this on your own instead of just waiting for me to help, just to type it for you. Don't be lazy. Okay, so Justice needs 2 1/2 or 2 5/10 tablespoons peanut butter per tablespoon jelly. And my handwriting is pretty sloppy, so that's why one of the many reasons I want you to be listening to the lessons out loud, okay? Because then you can hear it instead of just trying to decipher my horrible handwriting, okay? All right, for your summary. How do you turn a mixed number like 1 1/4 into its equivalent decimal? Answer that. Have a good day.